Hello everyone. Starting today's lecture, we'll be providing template notebook file for you to follow along with lecture demo problems. If you click on the code link as part of Dictionaries 2 lecture entry, you'll notice that there are two notebook files. One is template notebook file. The other one is the completed version of the template notebook file. Please pause the lecture video here and download the template notebook file along with tornadoes.csv. Let me show you what the template notebook file looks like. There will be two types of cells within the template notebook file. The first is code cell, within which you'll type in Python code. The second is markdown cell, which contains textual description. Eventually, we'll learn how to create markdown cells. For now, you need to read the textual description within the markdown cell and type the corresponding Python code as part of the code cells which appear below the markdown cell. We are going to get today's lecture started by considering an opinion-based question. If I were to ask you to pick one data structure between list and dictionary, what would your choice be? Go ahead and pause the lecture video here and think about the characteristics of list and dictionary data structures and make a choice. Write a comment in the comments section stating your choice of data structure along with a brief explanation as to why you made that particular choice. Let's consider the characteristics of the list data structure. With lists, you can perform operations like indexing, slicing, iteration using for loops. It is very easy for you to convert a list of strings into a string or a string into a list of strings using split and join methods. CSV files are typically represented using list of lists data structure. Here is a question. How do you represent a list data structure using a dictionary data structure? I have an example list L here, which contains items as strings A, B, and C. It is very easy for us to use dictionary data structure to represent a list. That's because we can use the integer index positions corresponding to the items as keys within the dictionary. L underscore dict is the corresponding dictionary for the list L here. Observe that I'm using keys as integers 0, 1 and 2, which are the index positions corresponding to the items within the list L here, and my values are simply going to be the items themselves. Let's discuss the characteristics of the dictionary data structure. It is very easy for you to look up the values within the dictionary data structure using the keys. Keys can be of any immutable type with respect to dictionaries. That is one of the most advantageous things about dictionaries. It offers way more flexibility with respect to labels when compared to list data structure. Insertion and update operations have the exact same syntax that provides another advantage. We can still iterate over the keys within the dictionary using for loops. What are things which you cannot do using a dictionary data structure and you can do using a list data structure? You cannot perform slicing operation or use methods like split and join on a dictionary. Let's consider the counterpart question, which is how do you represent a dictionary using list data structure? I have an example dictionary D here, which contains the keys as strings X and Y and the values as integers 3 and 9. Whenever you use list data structures to represent dictionary, you will have to define two different lists. The keys list here is keeping track of the keys in the dictionary, and the vals list here is keeping track of the values within the dictionary. How do you use a single for loop to iterate over a key value pair? That is very simple if you use the range built-in function. Recall that when you pass the length of a sequence as an argument to the range built-in function and use that range built-in function as part of the for loop, you're able to iterate over every index position within that sequence. Using one of the list variables length as argument to the range built-in function, we'll be able to extract both the key and the value by using indexing. I can simply say keys of index to extract the item in a certain index position within the keys list, and I can say vals of index to extract the corresponding item inside the vals list here. This particular for loop will only work when both of the lists have the same length. That is guaranteed for us because we are creating these lists to represent the dictionary data structure. It's a matter of choice as to which data structure you prefer over the other. You can use the template notebook file for going through the examples for various dictionary operations that I'll be covering as part of the slide deck for the rest of this video. I'm going to switch over to the slide deck. We are going to continue our discussion on the topic of dictionaries as part of today's lecture. We'll learn about dictionary operations. Specifically, we are going to learn about two methods called keys and values, which are applicable only to dictionary data structure. We are going to then move on to discussing about nested data structures. Recall that we have already discussed about one nested data structure, which is the list of lists data structure when we went through the topic of CSV. CSVs are typically represented using the list of lists data structure. In today's lecture, we'll be learning a concept called as binning or bucketing, which is performed using dictionary of list of lists. Then we are going to move on to learning about a new form of table representation using list of dictionaries. The last nested combination, which is dictionary of dictionary, will not be covered as part of the lecture video. I'll still leave the slide decks for you to go through if you're interested in learning about the application for dictionary of dictionary nested data structure. Let's learn about dictionary operations. Recall that you can create a dictionary by using open curly braces and close curly braces. Within those braces, you're going to use comma to separate the key value pairs. Every key is separated from its corresponding value using a colon. How do you create an empty dictionary? We have covered two different ways for that. The first one is just by mentioning open curly braces, close curly braces. Recall that you can also create an empty dictionary by saying dict open parenthesis, close parenthesis. The dict function is a special function called as constructor. Constructors enable us to construct a specific data structure, and the return value from the constructor can be stored into a variable which is now going to represent an empty version of that particular data structure. Let's consider how to create empty list and empty set. Recall that you can create an empty list either using the constructor function call by mentioning list open parenthesis close parenthesis, or by typing open square bracket close square bracket. How do you create an empty set? You only have the option of calling the constructor function to create an empty set by mentioning set open parenthesis close parenthesis. Let's go through the len, in, and for operations for a dictionary. I have num underscore words dictionary here, which contains four key value pairs. The keys are integers 0, 1, 2, and 3. The values are strings 0, 1, 2, and 3. What will be the output of len of num underscore words? That's going to be 4. That's because the len function counts the number of key value pairs within your dictionary. Be careful here. This is not going to give you a value of 8, which is the number of total keys and values within your dictionary. Instead, len function only counts the individual key value pairs. So you're going to get the value of 4 for num underscore words dictionary here. Let's talk about the in operator. Recall that we went through use case for in operator and for loop as part of the scores demo in previous lecture. The in operator works differently for a dictionary. You're going to look up whether a particular key is part of the dictionary or not using the in operator, which is very different from the application of in operator for a list. For a list, you're going to look up whether a value is part of the list or not. Let's go through examples. If I say integer 1 in num underscore words, that's going to return a boolean value of true. That's because the key 1, which is integer 1, is part of the num underscore words dictionary here. What will be the value when I say string 1 in num underscore words? That's going to be boolean value of false. That's because the string 1 is a value. The n operator only enables you to look up existence of a key. Let's go through example of a for loop. Recall that the for loop for a dictionary enables you to iterate over keys, which is very different when compared to for loop over lists. For loop over lists enables you to iterate over the values within the list. If we were to say for x in num underscore words colon and use the print function call to display x, that's going to display the keys which are integers 0, 1, 2, and 3. This particular order, which is the same as the insertion based order, is guaranteed only for Python version greater than 3.6. How do we obtain the corresponding values? Recall that you can use the lookup operation to do that. We can simply say dictionary variable name, which is num underscore words, open square bracket, key, close square bracket, and that's now going to display both the keys and the values for every iteration of this particular for loop. Let's learn about keys and values method calls. Keys and values method calls are applicable only to the dictionary data structure. The purpose of the method calls is fairly straightforward. The keys method call enables you to obtain all the keys from the dictionary. The values method call enables you to obtain all the values from the dictionary. Recall that the syntax for method calls in general is going to be the variable name dot method name open parenthesis close parenthesis. We'll have to follow a similar syntax for keys and values as well because those are methods. Let me talk about what you will get when you invoke the type function on the return value of keys and values method call. You'll see something which is called as class. We will not be covering the concept of class as part of this particular course, so you don't have to worry as to what class means. All that you need to know that it's very easy to convert the return value of the keys and the values method calls into a list by simply typing list open parenthesis close parenthesis around the method call here. So the keys method call for num underscore words, once you convert that into a list, is going to give you the list of integers 0, 1, 2, and 3. Correspondingly, the values method call will give you the list of the values strings 0, 1, 2, and 3. Let's learn about get and pop methods for a dictionary. Recall that the pop method for a dictionary enables you to remove a specific key value pair from the dictionary and it will return the removed value as the return value. Let's consider an example dictionary suffix here where we have three key value pairs. The keys are 1, 2, and 3. So if you were to invoke pop method by saying suffix.pop of 0, that's going to fail. Naturally, you cannot remove a key value pair which doesn't exist within that particular dictionary. That same concept is applicable for lookup as well. So you cannot say suffix of 4 because the key 4 is not defined as part of the suffix dictionary. Let's learn about the get method and default values for get and pop methods. The get method performs the same operation as the lookup that we do by mentioning dictionary variable name open square bracket key close square bracket. The only difference is that the get method supports a default value as argument. What do I mean by that? You're going to use the get method to perform the lookup by passing the first argument as the key whose value you want to look up. The second argument is going to be the default value that you specify. When the get method cannot find the key that you pass as argument 1, it's going to return the default value that you pass as argument 2 here. Similar to default values for get method, you can have default values for pop method as well. Instead of just invoking suffix.pop of 0, I could say suffix.pop of 0, comma, string th. Now the pop method call will succeed even though the key 0 does not exist within the dictionary suffix here. Let's go through a use case for the default values for get and pop. Let's say that I want to use this suffix dictionary to create ordering of numbers from 0 to 5th. I can simply do that by writing a for loop which uses range built-in function and pass 6 as argument to that particular range built-in function. Recall that the range built-in function returns the values as 0 up until one value minus the argument. So this particular for loop is going to run for num values of 0, 1, 2, etc. up to 5. Within the for loop, I can just invoke the get method and pass num as the lookup key and also pass the string th as the default value. Why are we passing th? That's because th is the most common suffix when it comes to ordering of numbers, correct? You have 0th, 4th, 5th, 6th, and so on. The only exception would be when you have 1, 2, or 3 as the last digit. That's when you're going to say first, second, or third here. And of course, you have the exception for 11 to 20 where you're going to say 11th, 12th, and 13th. This particular simple version of the code will work for ordering of numbers from 0 up until 20. For 21, it's going to break because you'll have to extract the 1 out of 21 by using the mod operator, and then you'll have to invoke the get method. Recall that we went through the entire example for ordering of numbers as part of the conditionals lecture. You can imagine combining a dictionary concept with that particular solution and making it more concise. I'll wrap up this lecture video here. In the next video, we'll talk about the dictionary of list of list nested data structure.